So, good morning students. Welcome to the design and detailing of the RC structural elements lab. So today we'll be learning the design and detailing of the staircase. So now before we go to the design and staircase, we'll learn some of the basic important components which is to be remembered when we are designing the staircase. So now the slab which is provided of a certain thickness below the stairs, we call it as waste slab, and the vertical panel which is going to be provided in the stairs, we call it as a riser, and the horizontal panel which is going to be provided in the staircase, we call it as tread, and the extra projection which is provided, we call it as nosing. And when you have the two staircases one above the other, from the bottom of the staircase of the topper staircase to the top of the riser of the bottom stair, there should be a minimum clear height of 2 meters. This is to provide a sufficient headroom for the staircase. This diagram shows you the plan, the top plan of the staircase. The length of the projection where all the staircase are provided, we call that as flight. Flight represents it is a length where all the stairs are present. So, and it is also called as the going of staircase. And once you climb the staircase, there will be an area to stand or to take the rest, and that area we call it as landing. It may be provided both at the beginning of the staircase as well as at the end of the staircase. Similarly, this landing will be supported on the beam at the outermost part, and these beams we call it as supporting beam. And to the extreme parts of the staircase as well as landing, will be providing the handrails for the safety purpose. Now this diagram shows you the cross section of the staircase. So when we are seeing the longitudinal cross section, so this slab we are going to call it as waste slab, and for this waste slab itself we are going to provide the reinforcement, and this is what we call it as riser, this is what we call it as tread. And this staircase can be made up of the concrete or maybe brick or maybe timber. Now these slides will give you some of the different types of arrangements of the staircase. The first one is called as the straight stairs, where all the stairs are provided at a one step itself. The second one is the quarter span, where we are going to turn at a 90 degree. The third one is the dog-legged staircase, and this is the one that we are going to design. And the fourth one is called it as open well staircase. These are some of the other arrangements. So the first A and B, these two are the straight flight stairs. The third one C is the quarter turn stairs, and D is the half turn stairs, and E is the branching stairs which can be observed in public buildings. Then F is the open well or half turn stairs, and G is the open well stairs with quarter turn landing. Then H is the part circular stairs, and I is the spiral stairs, and J is the helical stairs. So these are some different types of representations of staircase. So now in your design and detailing of this staircase, we are going to concentrate only on the dog-legged staircase. And now this is a small part of the landing slab, and this gives you the reinforcement details of the landing slab. So the landing slab will be supported on a beam, and this beam we call it as the stringer beam, which will be designed and detailed as the same of your normal beams what you have done in the previous class. Now in this landing slab we will be providing again two types of steels. The one with the continuous line we call it as the main steel, the one with the dotted we call it as distribution steel, right? And from here to here, whatever the extra length of the steel or the reinforcement we are providing, that is the development length, and that area is equal to 0.5 AST of the steps. Okay, so this is how the general cross section that we are going to see. This figure helps you to calculate the effective span of the staircase. Always the effective span of the staircase should be taken from center of the landing beam to the center of the one more landing beam. If in case the landing beam is absent, then you have to consider from the center of the support to the center of the one more support. For example, in this beam the stair is provided exactly with the help of landing beam. Therefore, from here the center of landing beam to this center of landing beam we call it as effective. If you see this diagram, so there is no any landing beam exactly at the beginning of the staircase as well as at the end of the staircase. So therefore what they have done is they have taken the effective span from the center of the landing beam which is provided in the landing slab to the center of the support of the one more landing slab. So that is how we have to. Now this slide will give you the detail or the shortcut way of calculating the effective span when you have the landing on both the beginning of the staircase as well as at the end of the staircase as well as the flight. Now the one with the beginning of the staircase landing they have taken it as y, the one at the end of the staircase landing they have taken it as x, and the staircase flight they have taken it as going, that is g. So therefore, if the width of the x is less than 1 meter and y is also less than 1 meter, then the total span we are going to take it as g plus x plus y. If x is less than 1 meter and y is greater than or equal to 1 meter, then we are going to consider the span as g plus x plus 1. If x is greater than or equal to 1 meter and y is less than 1 meter, then the span we are going to take it as g plus x plus g plus y plus 1. Then if x is greater than or equal to 1 meter and y is greater than or equal to 1 meter, then we take the span as g plus 1 plus 1. This is how we have to take it. Now this diagram will clearly indicate you the reinforcement detailing of the RCC staircase. Now first we will see the reinforcement detailing of the waist slab. Now if this is the total thickness of the waist slab, at the bottom of the waist slab we are going to provide the main steel reinforcement. That is from beginning of the stair to the end of the stair we are going to provide the main steel reinforcement, and above this main steel reinforcement we are going to provide the distribution steel reinforcement. Now once the staircase is going to end and we are going to reach the landing, the main reinforcement of the waist slab which is provided at the bottom will be extended up to the top of the landing slab. So in the top of the landing slab it will be provided up to the end of the landing slab. So then the distribution reinforcement at the top of the landing slab will be provided below the main reinforcement, and the main reinforcement at the top of the landing slab will be the continuation of the main reinforcement of the waist slab. Now along with that, at the landing slab we will be providing the one more reinforcement at the bottom, and that is the main reinforcement, and above the main reinforcement we will be providing the distribution reinforcement. But this main reinforcement again it will be projected into the staircase and it will be bent to a certain distance, and when it is projected out of the slab, that is landing slab, there the distribution reinforcement will be provided at the bottom, and from the beginning of the stair and the extra projection whatever we are going to provide, that will be the development length which is equal to 47 times the dia of the reinforcement. This is how the reinforcement has to be provided at the staircase, even at the top landing as well as at the bottom landing. This is the one more similar diagram representing the reinforcement detailing of the staircase. Now we consider a problem, right? So in this cantilever beam type of staircase, so we have two beams of width 300 and depth 450 mm provided at the first riser and at the edge of the upper landing. they have already calculated the effective length of the staircase is 4.5 meter and the width is 1.5 meter. The floor height is 3 meter and the landing at the top floor being 1.5 meter. The overall thickness of the waste slab is 230 mm, including 20 mm clear cover. The riser is 150 mm and the tread is 300 mm and use M20 crown concrete and Fe415 steel. And to decide the amount of exposure, based on the amount of exposure of the steel, we have to decide the cover from the building, the effective depth of the waste slab. They have told 12 bars of 140 mm center to center at the bottom of the stairs, out of which alternate bars are bent up. This is the main steel reinforcement. 8 mm dia bars at 150 mm center to center is the distribution steel. Now, if we see or if we consider this diagram, again this is a waste slab of 230 mm thick. Now, from the beginning of the staircase to the end of the staircase, totally we have 3 cross section at XX, at YY, at ZZ. Now, from the beginning of staircase to the end of the staircase, there will be two reinforcement which will be provided throughout the staircase, right, and that will be provided at the bottom of the waste slab, and the line which is continuous line, so that will be the main reinforcement, and the one with the dotted will be the distribution reinforcement. Now, the same main reinforcement which is provided at the bottom of the waste slab will be continued inside the bottom of the top landing slab. See here, the main reinforcement of the waste slab has been continued in the bottom of the top landing slab as the main reinforcement, and above that itself we are providing the distribution reinforcement also. Now similarly, if you see the bottom landing slab, again the main reinforcement which is provided at the bottom of the waste slab will be continued as main reinforcement in the bottom landing slab, and above that we will be providing the distribution steel. Now, what about the top reinforcement of the bottom landing slab and top landing slab? If you see here, the top landing slab will have the main distribution at the top, and below that we will be having the distribution reinforcement. Now, once if you project that into the staircase, then from here to till here, whatever you are going to provide is the development length. So here in this development length, this will be your main reinforcement, and above that you are going to provide the distribution reinforcement. But here this will be main, below that will be the distribution. But here from here to here, above will be the distribution. Now similarly here also, you see this. So this is the main reinforcement, and below that you will be having the distribution. But from here up to the development length till here, this will be the continuation of the main reinforcement of this top landing slab, and here the distribution reinforcement will be provided at the top. Here the distribution reinforcement will be provided at the bottom. This is how we have to consider. That's why if you take section YY, we can see only two reinforcements. One is main reinforcement of the waste slab, one is the distribution reinforcement of the main slab. But if you see, second is at the bottom landing slab, so this is the main reinforcement of the waste slab, this is the distribution reinforcement of the main slab, this will be the main reinforcement of the bottom landing slab from the top, and this will be the distribution reinforcement. Similarly, if you take section at ZZ, okay, that is at the top landing slab, so this will be the main reinforcement of the waste slab, which is the continuation. This will be the distribution reinforcement, whereas this will be the main reinforcement, which is the continuation of main reinforcement of the top landing slab, and this will be the distribution reinforcement. That is the one more section at YY. The diagram which shows all the three sections as well as longitudinal section at 1. So this completes your design and detailing of the staircase. Thank you.